Hello class, this video is going to focus on 1.6, which is locating points on a coordinate plane. There are two goals for this video. The first is I can find a point on a directed line segment on the coordinate plane that is a given fractional distance from the initial point. And the other goal is I can find a point that partitions a directed line segment on the coordinate plane in a given ratio. You want to open your textbook, turn to page 43 where you will begin to take notes. So you can find a point on a directed line segment that is a fractional distance from an endpoint on the coordinate plane. The coordinates of a point on a line segment that is a over b of the distance from the initial endpoint a, x1, y1, to the terminal endpoint c, x2, y2, are given by this formula, where a over b is a fraction of the distance if b is not equal to 0. And you don't want b to equal 0 because you cannot have 0 on the bottom of a fraction because you can't divide by it. Okay, example 1, fractional distances on the coordinate plane. This is on page 43. So you want to find point C on segment AB that is 3/4 of the distance from A to B. So step 1, we want to identify the endpoints. So identify the initial and terminal endpoints. So the initial endpoint is always on the left side. So point A is our initial endpoint. So x1 is going to be -7, y1 is going to be -5. And then x2, y2 is the point on the right. So B is our terminal endpoint, and that would be x2, which is 6, y2, which is 8. Okay, so those are our initial and terminal endpoints. Step 2 is to find the x and y coordinates using the formula for fractional distance. So here's the formula for fractional distance. We have x1, y1, x2, and y2. And that is listed up here. I'll just label it again. x1, y1, and then x2, y2. And then a over b is 1/2, I believe. Let's see. Oh, sorry, 3/4. 3/4. So A equals 3, B equals 4. Okay, so we're going to take those numbers and substitute them into our fractional distance formula. So x1 is -7 plus A over B is 3/4. And then times the quantity x2, which is 6, minus x1, which is -7. Okay, and then we're going to do the same for our y values. So y1 is -5 plus a over b, which is 3/4, times the quantity y2, which is 8, minus y1, which is -5, and then close all the parentheses. And then you can use a calculator to do the math. So we'd have 6 minus -7. So that's 6 plus 7, which is 13. And then 13 times 3, which is 39/4. So that would be -7 plus 39/4. And then over on the y's, we have 8 plus 5, which is 13. 13 times 3, which is 39. So we've got -5 plus 39/4. over 4. Okay, so then if we throw that in a calculator, we can get a decimal, and that decimal is going to be 2.75 and 4.75. So point C is located at 2.75, 4.75. Okay, next example, we want to find the coordinates of point X on the coordinate plane. This is going to be number 2 on page 47. So we have point X on segment RS is 1/6 the distance from R to S. So RA over B is 1/6. And then our X1 is point R, X1, Y1. And then our X2, Y2 is point S, so X2, Y2. And then we're just going to substitute that into our formula. So for X1, I have -4 plus A over B is 1/6 times the quantity X2, which is 2, minus -4. And then for Y, we have Y1, which is 2 plus 1/6 times Y2 is -2. Y1 is 2. So -2 minus 2. Okay, so then we just need to simplify it. So we've got 2 plus +4. That's 6. 6 divided by 6, or 6 times 1/6 is 1. 1 plus -4 is -3. And for our y values, we've got -2 minus 2, which is -4. -4 times 1/6 is going to be -2/3. And then plus 2. So I'm going to get 2 to be a fraction. And 3 is going to be my common denominator. And that's going to make 6 over 3. So then I'm going to do 6 minus 2, which is 4 over 3. And again, you can use a calculator to do the math. And we can put that on the graph just to check. Sorry, it's not -4/3. +4/3. Okay, so -3, +4/3. So 4/3 is about 1 1/3 up. So if we go on the graph to -3 up 1 1/3, right there, that's about 1/6 of the distance from R to S. Okay, so using the section formula on the coordinate plane, so if A has coordinates x1, y1, and C has coordinates x2, y2, then a point B that partitions, remember partitions means divides the line segment in a ratio of m to n, has coordinates. And here is our formula. So it looks very similar to what we used when we were on the number line. Now we're just adding the y value since we are on the coordinate plane. Okay, example 2, locating points on the coordinate plane with a given ratio. This is page 44. So find C on segment AB such that the ratio of AC to CB is 1 to 2. So they give us our A, they give us our B, and this ratio is 1 to 2. Okay, so I'm just going to write down the ratio so I remember M to N is 1 to 2. And then for our X1, Y1, we have point A, and X2, Y2 is point B. And we're just going to substitute those in. So in place of N, I've got 2 times X1 is -5 plus M is 1 times x2, which is 6, and that's over m plus n, so 1 plus 2. Okay, and then we're going to do the same thing for y. So we've got n, which is 2, and then y1, which is negative 2, so times negative 2, plus, and then we have m, which is 1, times y2, which is positive 2, and then that's over 1 plus 2. Okay, so then we just need to simplify it a little bit. So we've got 2 times negative 5, which is negative 10 plus 6 is negative 4. And then 1 plus 2 is 3, so negative 4 over 3. And then we have 2 times negative 2, which is negative 4, plus 2, which is negative 2, negative 2 over 3. And that is our point. So at that point on the line, it will divide the segment into a 1:2 ratio. Okay, last one, we want to find y on segment MN such that the ratio of my to yn is 1:3. So 1:3 is our m to n ratio. And then m is our x1 and y1. And we have to actually find the points because they don't give us the exact coordinate. So m, let's see, I'm going in the x direction, negative 6. And then in the y direction, negative 4. And for n, so n is x2, y2. So n is 6 for x2, and then 4 for y2. Okay, so I'm going to substitute those numbers into my formula. So in place of n, I have 3 times x1, which is negative 6, plus m, which is 1, times x2, which is positive 6. And that's going to be over m plus n, which is 1 plus 3. And then the y values, we've got n, which is 3, times y1, which is negative 4, plus m, which is 1, times y2, which is 4, and then that's going to be over 1 plus 3 as well. So let's simplify the top. We got 3 times negative 6, which is negative 18. Negative 18 plus 6 is negative 12. And then on the bottom, we got 1 plus 3, which is 4. And I'm just going to divide that. Negative 12 divided by 4 is going to give me negative 3. And then for our y values, we've got 3 times negative 4, which is negative 12. Negative 12 plus 4 is negative 8. And then on the bottom, 1 plus 3 is 4. And then negative 8 divided by 4 is negative 2. So our point that partitions the segment is going to be negative 3, negative 2. Okay, that is the end of 1.6a. Remember, in order to move on, you need to get at least a 75 on the quiz for this video.